Apologies, folks, for being a few minutes late. We got a little bit carried away on the issues PR meeting and didn't realize that we'd run a bit over. As you might imagine, with the release coming up, the issues PR meeting has gotten more involved. All right. So let me go ahead and stick this in the chat. If folks could go and add themselves to the attendees list, that's extremely helpful. All right. And we're coming up at about 5 after, so I guess we'll go ahead and get going. Sadly, Frederick will not be able to join us today. He had something that came up. So let me go ahead and share the meeting minutes. Excellent. So again, please add yourselves to the attendees list. That's very helpful. So we have this meeting every week at 8 a.m. on Pacific time on Tuesdays. There's an issues PR meeting that's also on our calendar that precedes this meeting directly. And of course, it's public and open and everyone is welcome at it as well. But just by way of expectation, the issues PR meeting, we're literally just walking a project board, working through the issues in PR, which is fascinating and important if you're engaged with the project at that level, but otherwise less interesting. So these are sort of broader community meetings. So also in terms of agenda, we have other recurring events we participate in. CNCF has a weekly CNF working group that happens on Mondays at 1600 UTC. And there's also CNCF SIG Network that we participate in that's on the first and third Thursday of every month at 11 a.m. Pacific. So highly encourage folks to attend those meetings. For the first time ever, and that's saying a lot because our social community media team hasn't actually updated here, but given their normal, incredible degree of reliability, I'm certainly not all that displeased. So we will skip over the social community and media stuff. By the way, please feel free to add anything you would like to the agenda. We run an open agenda in this call, and as you can see, people just add things as they go. And that's not only perfectly fine, it's actually incredibly nice if you go ahead and add your stuff here. So really quickly looking at the agenda, we've got discussions about the NSM release, which will be a continued topic of conversation as we move towards it. I wanted to give Perry an opportunity to talk about the progress on refactoring things for the OVS forwarder. It looks like someone has added a VLAN forwarder demo. Is there anybody who'd like to see the order of these items reshuffled or feels that there's something else they need to add to the agenda for today? All right then. So just jumping into the NSM release then, and I'll go back to the NSM release slides just to bring focus to sort of the priorities. So our proposed target date for the release is June 8th, which is 3 weeks from now. And we sort of laid out priorities in terms of things we'd like to see there. So, on the feature priorities, the first one is we still need a remote IP payload mechanism. We want very much for that to be WireGuard, and it looks like that actually will come to pass. I think we've worked out a plan for getting that there fairly quickly. So that's good news. I know that we discussed in the issues PR meeting that interdomain and floating interdomain are coming along nicely. And then on the P2MP enhancements, that's one where I'd like to at least get the pieces in necessary for that, but we'll have to see sort of how things go. There are some things in flight right now around the healing testing that make that a little bit iffier than I had hoped, but we'll see. I'd still very much like to get that done. Proposed testing priorities. So obviously getting all the package AKS, and EKS testing going. Quick check. Am I correct, Artem, because I know you've been monitoring this, am I correct in saying that testing is working in EKS, AKS, and packet generically? Is that true?
Yeah, AKS and EKS, it's working, all tests are working correctly.
Okay, and then I think you figured out that there's a subtle neighbor issue in GKE that you're chasing down.
Yeah, there is a small problem. Yeah.
Okay, that's good. Composition testing is coming together nicely. The healing tests are underway. Data plane performance testing, I don't think we have coming up right now. So if there are folks who would be interested in getting some of that going, that would be very welcome. And then scalability testing. Continuous upgrade testing is sort of unlikely for this release, but it's on the priority list. But what we will get that moves us in that direction is the release repo. So in terms of release mechanics, we could always use help for documentation. I think we probably want to try and get documentation that's user-facing up on the website. And then we're going to probably proceed with a release repo. And again, as was mentioned last week, the proposed future cadence would be quarterly with the next release around August 31st. So even if the P2MP enhancements don't make it in this time, I see no reason they shouldn't make it into the release for August 31st. And I think there were some comments about folks who were doing things like the OBS forwarder who would also like to sort of queue themselves up for August 31st. Is there anything else in terms of questions, comments, et cetera, that folks want to raise here? And or people who want to volunteer for helping getting this moving? All right then, so let me go back here. So progress on refactoring for the OVS forwarder stuff. Do you want to comment on this, Perry? I know you've been very busy.
Yes, yeah, as we discussed last meeting, so we needed some enhancements in the SDK repos so that we can have maximum code reuse in the OVS forwarder. So last week, I raised a couple of issues across the SDK repos. And after that, I started working on relevant pull request. So right now, there are some reviews ongoing on the PRs. Yeah, it's going very good right now.
Excellent.
So it's on progress, yeah.
That's fantastic. Glad to hear it. No, I appreciate you picking up a shovel and just really starting to move pieces around. That's actually quite good.
Okay, thanks.
Then we had some folks who wanted to do a VLAN forwarder demo.
Yep. Can you hear me okay?
I hear you fine.
All right. So I'll try to share my screen.
Yeah, let me stop sharing my screen because otherwise it may give you trouble sharing yours.
Right. Does it look okay?
Mm-hmm.
All right. Yeah. So basically, this is a continuation of the VLAN forwarder that we presented previously, with some new additions and adaptation to the multi-repo. So, right. So basically, the idea behind this is to facilitate external connectivity. So this forwarder is a bit different to like the common setup. But in general, this is the procedure, and it's the same like we presented before, but just as a recap. So we have this setup with an endpoint that will provide the VLAN interface. And we have some external router or any external entity that is connected to this ETH2 network. But basically, we start with deploying this VLAN-enabled endpoint. And we deploy a number of clients, and they request to be connected to this service. And yeah, the next step is, well, it's a bit unorthodox as far as forwarders go, because there are only interfaces injected on the NSE side, so there is no interface created on the endpoint.
Really quickly, we should. There's a whole conversation to have there after your demo, because that's actually exactly the kind of things that we do with the SRIOV forwarder. So okay. It's not as unorthodox as you think.
All right, cool. All right, so then this approach might be a bit more familiar then. But yeah, so basically we create these interfaces, and after that we're able to address all these containers individually from an external node. And of course you can make this use case more complicated, but yeah, as an illustration, this yeah, should visualize the concept. So this is what we already presented basically, but at that time we were using NSM 0.2, and these are some updates. So we moved to the multi-repo, and it's based on that. And instead of combining this functionality into like a double forwarder with like combined with the kernel forwarder, we now have a separated one. And in order to select this forwarder, we've introduced a unique VLAN mechanism. So yeah, that's the new approach. And the configuration for the VLAN is set on the NSE. So basically the range as usual. And then we have the interface name that we will base the VLAN on top of. And yeah, what VLAN ID to use. And how to select that we want to use the VLAN is just this to specify it in the in the NSE configuration with yeah.
Okay.
Basically like this.
Yeah, that one there's a little bit more of a conversation on. This is all sort of like how one conceptualizes this, and it's not a matter of rights and wrongs. It's sort of a matter of taste. So don't take me too seriously. The way I would tend to think about this is still a mechanism kernel, because the actual thing dropped into your pod is still a kernel. But the remote mechanism in this case is VLAN, right? So the pods are asking for a kernel interface, and then you're choosing to drop a VLAN interface into them. So a quick question, are you having the NIC handle the VLAN push pop?
Can you say that again?
Are you having so the VLAN tag, is that being pushed and popped by the NIC?
I mean, we don't really have control of that. We just assume that whoever configures the NSE will know what to use. Okay,
so you're basically, the thing I'm sort of wandering around in my head about, and there's a whole conversation to be had here, is your NSEs, as you've written it here, they have to actually know that they're asking for a VLAN, correct?
Yeah, I mean, basically the selection we've implemented that we thought might be, I mean, basically if we use the kernel mechanism, then it's hard for NSM to be able to pick, to differentiate between the VLAN forwarder and like any kernel forwarder.
Okay. Right.
So basically, so basically, we introduced this in order to make sure that we get the VLAN mechanism.
Right. But I guess the question is, so like from the global view of the world, where you're looking at the whole system, I totally get it. You want to be able to make sure you get the VLAN mechanism.
Right.
From the local view of the world, from the point of view of somebody writing an NSC client, that's sort of leaking a lot of information to them, where they have to suddenly understand the existence of VLANs and that they want them and why they would want them, if that makes sense.
Right. So I mean, we would be very happy if we had some alternative way to
that's what I'm trying to sort of
forward selection.
That's kind of what I'm trying to figure out, which is, you're basically, so these are going through the forwarder to an NSC, correct? And the NSC is making a decision about the VLAN tags, right?
I mean, basically, if the NSE is supporting this mechanism, then it will be accepted. Otherwise, it won't be, right?
Well, so do you have a forwarder in the picture at all, or is it just the NSE?
I mean, we definitely have the VLAN forwarder.
Got it. Mm-hmm. So I guess my question is, one thing you might do, basically one thing you might do is to, and this is the beginning of a thought, not the end of it, because it doesn't fully solve your problem. If the network service endpoints are coming up and they're asking for a service by name, right? So they're asking for the name of a service with a kernel mechanism, right? Because that's really what, from their point of view, what they want is a kernel interface that lands in their pod. That thing goes to the forwarder. The forwarder then looks up the NSE and it sends the request to the NSE. The NSE is actually capable of specifying the VLAN mechanism as a remote mechanism, which then goes back to the forwarder. The forwarder can then look at the remote mechanism that it's received from the NSE and say, okay, on one side, I've got somebody who wants a kernel interface. On the other side, I've got this entity that basically wants this to go out over a VLAN, that says that when it hits the real network, it needs to be on a VLAN. So I'm going to make I'm going to take the correct action to make sure that there's a kernel in that NSE, and that when it hits the network, it has a VLAN tag. Does that make sense? You're essentially cross-connecting the NSE to a VLAN when it hits the real network. And then the forwarder has to be cognizant of how to do that, but the actual NSE doesn't have to be aware that there might be a VLAN when you hit the real network. Does that make sense?
Right, but if you actually want to make sure that you know that the client wants to only connect to the VLAN, can you do that with the mechanism you mentioned now?
The question is, does the client want to only connect to the VLAN, or is the client asking to be connected to a bridge domain that happens to be represented on your network by a VLAN?
In this case, it's actually requesting the VLAN connectivity, like specifically.
Right, but my question is...
I think it wants to be connected to a bridge domain. Whether or not this is a VLAN and which VLAN it is doesn't really matter, I think.
Exactly my point, right? When somebody comes through and says, oh, we don't want to use VLANs, we want to use, oh God, I've forgotten the L2BGP thing. I'm drawing a blank on it. We want to use that instead, right? Or some other person comes through and says, well, we actually are running L2 Ethernet frames over SRv6 or whatever. Like the client's actual semantic ask, I don't think changes because this client really just wants connection to a bridge domain. How you get connected to that bridge domain might be a VLAN, absolutely, but it's not really the client's thing, right?
I agree.
Okay.
And I think what you sketched earlier, that you basically defer the decision until the very end, until the NSE comes back and says this should go through a VLAN remote mechanism. And then the chosen forwarder says, oh, I can't do it. I return an error. And then you have to redo everything again. That's maybe it will work, but it's not really a good solution. Well, and we have been discussing this internally before, and I think the right solution would be to use the tools that we have kind of designed as part of the point-to-multipoint.
Right. So, I mean,
to do forwarder selection through annotation in the service spec, so that we pick the correct forwarder or a suitable forwarder from the beginning.
Yeah, that very well may be, that absolutely very well may be the issue. And I absolutely understand your general concern with sort of having to, in a multi-forwarder case, having to fail through to the correct forwarder for this. You know, I absolutely understand the potential for that to be an issue. I do, however, and not in the way of discounting the potential issue, because I think the potential issue is very real. I do want to point out that right now, what it's taking to successfully traverse through a forwarder in the testing that I'm doing is somewhere between 40 and 100 milliseconds. So you would be adding something less than that in terms of overall latency to the system to fail through to another forwarder, because they are actually local to you. So not saying that necessarily is acceptable. I'm just saying that my general intuition about the fail through stuff is more concerning when I don't look at the actual latencies involved. And when I look at the latencies involved, I'm less concerned. And you're gonna have to tune how much that actually matters to you, because it very well may. But the common intuition we all have is that that would be slow. And that depends very much on your definition of slow.
Okay. Ed, another question. Would your scheme also work if the NSE is actually local to the client? Because then there is no remote mechanism involved.
Well, I mean, this actually gets back to an interesting question that Perry's raised on the SRIOV forwarder that I'm actually sort of starting to have a discussion with him about over there, which is the notion of local and remote may need to be thought about a little bit more, if that makes sense, because the fact this was one that you guys suggested a year ago that I thought was really cool, which is the fact that the thing that answers the call and tells you to use this VLAN ID happens to be running on the same node doesn't necessarily mean that it's on the same node, right? So you're right, we may have to think through that a little bit more as well.
Anyway, so I mean, our intention with this is definitely that what has been discussed as this part of this point-to-multipoint solution is a preferable way. It's mostly that we were thinking about how can we solve, like how can we perform what we are looking for today with the current state of NSM.
Yep. Well, and I guarantee you, here's the thing, I guarantee you that people are going to be interested in doing something that's shaped like this, right? Where they have network service endpoints and they want them to be connected to some externally facing VLAN or possibly some externally facing MAC VLAN solution. That's going to be an absolutely real thing.
Right. Okay, but maybe do you think there might be some alternative solution even now, like before we have NSM version 1.0 that could perform this selection without too many changes, or?
Well, so I mean, you mean in terms of performing selection, the multi-repo selection stuff that Jan and I have been discussing?
Yeah, exactly. I got the impression that it might be in version 1.0 and perhaps later, but I mean, it might take some time.
Yeah, that's part of what we're trying to work out implementation-wise, and I think the first part of the stuff is actually going to be a little bit delicate. I know that you guys have expressed some willingness to pick up shovels and help on making the point-to-multipoint stuff go. So, right. Yeah. And so I guess the question really gets to that. So this forwarder that you've written, are you running this forwarder in a multi-repo scenario yet, or are you just running it a single, that's right, let me back up. You've based it on the multi-repo stuff. Are you running it at a multi-forwarder scenario yet, or are you just running it?
Right.
Okay.
Yeah, that's the use case we have. So, okay. And we also have an intention, like if it's possible, to start to upstream it. And that's why we figured like this might be a stopgap solution until we have like the final version for selecting the forwarder.
Yeah, so here's what I would strongly suggest that we start having the conversation around. Is definitely let's get a PR up to look at what a VLAN mechanism in the API repo would look like. Because number one, it gives us a good place for discussion. Number two, we know that one way or the other, we're going to want something shaped like a VLAN mechanism. I happen to have a tendency to view it as a remote mechanism. That doesn't make me right. It just makes me somebody who has an opinion. But if you could go ahead and open a PR for sort of the API changes to support a VLAN mechanism, because whether we're talking about the way you're doing it here, or we're talking about the some other way of doing it, it is going to be a thing that people are going to want to solve. Is going to be VLAN and MAC VLAN mechanisms. Quick question: is this actually just VLAN or is it MAC VLAN?
It's VLAN for now.
Okay, got it.
All right, but that sounds great.
Yeah, that's probably a good place to start, and it gives us an anchor point to sort of anchor the discussion about how to handle it.
Right.
Because you raised really good points, sort of all the way up and down, and it's easier if we can get this sort of exposed and hashed through.
All right. So anyway, I can just mention like how we set up the repos currently. So yeah, we forked two of the existing repos. And do you think we should make PRs on those, or?
Well, it sort of would depend on. So we've talked about moving a PR for the VLAN mechanism up into API. I think that's a good way to sort of structure it. And then in terms of the kernel SDK elements, feel free to open PRs. There's likely to be some discussion there around them. But I think they're likely to be productive discussion. So I would sort of, let's start with some of the PR stuff and we can hash this out as we talk through those things in the upstream, if that makes sense.
Yeah, sounds good. And then we also have this entirely new repo for an example of NSE to handle this. I mean, basically the settings I mentioned previously to be able to handle the mechanism.
Yep. No, this is good. Could you put a link to these slides on the agenda item?
Yeah, sure. I'll try to find a place to put them just.
Yeah, no, absolutely. Because I think people will be interested in some of these things. And the thing is, this kind of experimentation is exactly why we go to the effort of being modular, right? Because this is, what I really like is ideas that come out, that express themselves, that are not the way I would have solved the problem. Because number one, often they're good ideas. But number two, it means that there's enough space for independent innovation in the system. And that's, I think, really important.
Right. So how do you think we should handle this entirely new repo? Do you think there might be a possibility to add that one, or is it enough with a link?
So let's start with the link, and then we can sort of talk about when and how you would like to upstream that into, if you would like to move that up to the general network service mesh organization. We have a bit of a different naming scheme for repos, but that's not really neither here nor there. That can be easily fixed. But I think that what's in your NSE repo is may potentially be somewhat influenced by the outcome of the discussions about the API and SDK elements. So
of course,
it's probably a good thing to hash through those discussions. But overall, having useful NSEs landing up in network service mesh is generically welcome. Not that you have to, but you can, right? And then the other thing we'd want to discuss when it gets up there is we have a tendency for those things to want to line up committers who will actually love them and take care of them. So that would probably look like the people who are currently looking after that particular NSE.
Right. Okay, but let's start with the other two then.
Yeah, I think that's probably a good idea.
Right. Nice.
Cool. Anything else?
Yeah, I mean, we have a brief demo as well.
Oh, that's fantastic.
So perhaps, Laszlo, are you ready?
Yes, I'm here.
All right. Then I'll hand it over and stop sharing.
There we go. That's much better.
Okay. So I prepared an environment, a Kubernetes node in some with some this 4 nodes in that, and this one is an external node, and I added some VLAN link manually to this external one, and I'm going to start the NSM elements. We have some the registry and the NSMGR started. Now I started the forwarder and the NSC and some NSCs.
I don't know. Okay, there we go. Now your screen's updating.
And just to show some how it is configured on the NSC side, and let's check the client. We can see here the VLAN config in each client, and this is the IP and the interface. So the NSC provides the IP based on the this CIDR, and currently we use an own EPAM implementation, so it's not the point-to-point IPAM, but
yeah, that's fine. Point-to-point would be the wrong IPAM for this situation, so okay. This is good.
Okay, just to check the NSC, there is nothing created in the NSC side, and let's just ping from one of the see. We can
Fantastic.
see this running, and the same from the other side. That was all. If you have questions.
It supports scaling as well, right?
Yes. Yes, but now NSC is running in each node, so we cannot scale more, since only one NSC is
Right.
You started at the limit to scale. Yeah.
I think that relates to the question you had earlier, Ed. Since this is pure VLAN interfaces that are being created, there's only one per node. And I think you were after MAC-VLAN, because MAC-VLAN would actually allow the creation of multiple clients connecting to the same VLAN.
Yeah, and this is why I suspect that when the dust settles, well, this is a fantastic original demo and proof of concept. When the dust settles, it may be that what we want is actually a MAC-VLAN scenario, and not MAC-VLAN mechanism and not a VLAN mechanism. For exactly the reason you gave, because there's no good way of making sure that we only have one client per node in the real world. So
yeah, but MAC-VLAN in itself is I guess implementation detail of a kernel forwarder providing this kind of functionality. With VPP, I guess you would not use MAC-VLAN, right? If the VPP forwarder would provide this functionality.
Well, the thing is, MAC-VLAN as a feature is essentially just saying, well, I mean, you may be right. You may be correct about that. It may just be an implementation detail there, because probably the way you would do this, yeah, it may very well be an implementation detail of the forwarder now that you mention it. So you're correct. So.
Yep.
But I guess what we are after here is a service that could allow multiple network service clients to connect to the same VLAN on any number of nodes without any limitations, and being given MAC addresses that are unique, and L2 service, basically bridge domain service connecting all of them and external.
Right. You effectively, what you want is the ability to have a bridge domain service where the actual network service is being provided by your physical network via a VLAN. And that's from my perspective, that's actually kind of exciting, because one of the things that I've been talking about forever is, I don't care, your network service can be provided by a pod, it can be provided by a VM running somewhere, or it can be provided by your physical network. And so this is a great proof of concept of a network service that's actually being provided by your physical network. So, and that's exciting.
Right.
I have one quick question.
I think we should.
Maybe. Sorry, Jan, do you want to continue?
No, please ask your question, Dimitris.
Okay. I just had one question. Maybe I haven't understood this completely, but right now, to actually get access to VLAN 100, we had to spin up a network service endpoint that will actually provide our service to VLAN 100. So every time that we need to create a new VLAN, to have access actually to another VLAN, like VLAN 200, we need also to spin up a new pod, a new network service endpoint that will actually give access to VLAN 200. Is this the case, or?
Yeah, that's the setup currently.
Okay, so if you need access like to 1,000 external networks, then that means that you need 1,000 network service endpoints pod that will actually give access to those VLANs.
You could take your endpoint in a way so you would host multiple IDs, right?
Yeah, so you have a couple of options, because keep in mind what the network service endpoint in this scenario is effectively doing is just giving you back the sort of IPAM and remote mechanism stuff. And as is appropriate to a proof of concept, they've just got the one that does it for VLAN 100. However, there's no reason that you can't have a network service endpoint that either A, is providing any number of network service bridge domain shaped network services, however you would like them to be, right? So if you have 1,000 different VLANs, 1,000 different bridge domains you want to provide that happen to be backed by VLANs, you would have a single NSC that's advertising 1,000 different network services. Now, or, and this is actually the way I would recommend you do it, you could have a single sort of multi-bridge domain network service endpoint that has some label that allows you to semantically specify which bridge domain you'd like. Now, you've actually wandered into an example that I use all the time, which is I strongly urge people not to use the label VLAN equals 100 because you will hate yourself later. You really want to say something like bridge domain equals Pepsi, bridge domain equals Coke as your label. Because that's semantic, and when you decide that you want to go move what used to be on VLAN 100 to VLAN 223, everything still works. But you can have a single network service endpoint that's serving multiple bridge domain network services, and that happen to be backed by multiple VLANs on your physical network. Does that make sense?
Yeah, okay. Thanks a lot.
Yeah, no, but it's a very astute observation. And it's sort of the difference between semantically what's being done and sort of implementationally what's being done, because our implementations will progressively get more sophisticated, even though the semantics that the user sees is dead simple.
Yeah, and I just wanted to ask this question because I was not sure if I understood the POC correctly regarding if you need to have multiple NSCs, if you need access to multiple VLANs. That's why I asked the question mostly. I understand this is a POC. So yeah, I understand this is a POC, so this is like a first implementation, but just wanted to be sure that I understood everything correctly.
Yeah, no, it struck me as a very good question. I'm not sure how the folks who did the POC feel, but it struck me as a very good question.
Thanks.
Cool. Awesome. Anything else on this demo before we move to the next agenda item?
No, that was mostly what we had. And
final question I have, Ed. You said in the beginning the SRIV forwarder is basically following a very similar pattern, right? So it's not extremely new. How do you see it now after this demo? Is there, what is the overlap there? Are there differences in the approach that would warrant harmonization?
Well, so the place where I think the approach, the stuff we've already discussed about having a VLAN mechanism coming from the client, the way the SRIOV piece is looking at it, the SRIOV forwarder, the client is still asking for a kernel mechanism, and then it's passing a token that says, by the way, I got claim to some actual physical NIC resource, and then the remote mechanism comes back right now in the SRIOV forwarder as a no-op remote mechanism, meaning that, okay, we're just going to drop your SRIOV NIC in there, and whatever happens to be happening on that SRIOV VF, that's what it is, right? Whatever is happening for the PF, that's what's going on. And so in that respect, you're sort of got a similar notion. You have a client that would ask for a kernel mechanism, your network service would direct it to use a VLAN mechanism. And then, so for example, to sort of paint a picture, if you happen to be running on something that doesn't have support for SRIO, VVF kinds of stuff, then maybe you get a MAC VLAN interface stuck in by the kernel. If you happen to be running on something that has support for SRIOV, then and your SRIOV forwarder has evolved to support asking the NIC to push pop the VLAN tag. Then maybe you get an SRIO VVF that's dropped in that when it hits the PF will push pop your VLAN tag for you. Does that make sense?
Yeah, I'm completely following you. I think we have basically two flavors of the same thing here. Essentially, connecting to a VLAN on the physical network through different means, but essentially they are doing the same thing, and there will be another flavor of this coming with the OVS forwarder and virtual functions.
That's part of why
they all
talking
should
through
somehow
the semantics is important.
Yeah. we should all make them kind of look alike, and only very small differences in using them.
Yeah, and that's kind of what I'm getting at about the one to hash out good semantics, and that's part of why having different viewpoints is helpful, because you're much more likely to get good semantics with multiple viewpoints. Because ideally, what you'd like is a situation where the thing that you're actually getting from a user's point of view looks exactly the same, you know, modulo whether or not they have a claim to a piece of scarce hardware, and then the magic happens in the background. So, yep, cool. All right, then, let me go ahead and share the screen again. Can everyone see my browser? Cool. Yep. So the last thing I wanted to sort of mention more, in passing, is that there's a conversation happening over in the Calico VPP community, where effectively some folks have asked about connecting network service mesh to Calico VPP. For those of you who aren't aware, Calico supports multiple data planes under Calico as a CNI adapter. And there is a VPP data plane that's in, I think, tech preview right now that you can use as part of the Calico CNI. And one of the things that is super nice about network service mesh is it shares well, in that there is very little opportunity for it to collide with other users of a VPP data plane. And so there was a discussion about how you could run the network service mesh VPP forwarder using the same backing VPP instance that's being used by the Calico VPP CNI. And one particular advantage of this is the Calico VPP CNI tends to own the physical NIC on the box, which means that you get much faster performance in and out of the box, because if you're cross-connecting something, for example, out of the box via Calico, via that data plane, you don't have to go and opportunistically attach to a kernel NIC, which is quite slow for the node. Instead, you're flowing through something fast that is using that via direct user space stuff like DPDK or AVF or RDMA for Mellanox NICs, et cetera. And so there are some folks who are going to go try that out. We've gotten to the stage where we think that this will simply just work with a relatively minor set of labels, of environment variables set on the forwarder. But yeah, that's basically going on and struck me as being potentially of interest to folks, so I wanted to point it out.
We have discussed this before, Ed. I think what is needed for a standalone VPP forwarder to actually make use of a physical interface as a DPDK or RDMA interface. So do you think this kind of is complementary, or would this new angle obsolete the idea?
No, this new angle is entirely complementary, right? Okay. So effectively, from the point of view of NSM, 100% of this is exactly what you were asking for, with having the forwarder use a standard VPP that does that, right? So this is 100% complementary, because from network service mesh's point of view, there is literally no difference between the use case that you were looking for and this. It's exactly the same use case from NSM's point of view, which is we're talking to a VPP that we didn't run ourselves, but somebody else is running it. And we are, and that VPP, whatever magic is needed to be done to make that VPP run on the whatever magic needs to be done to make that VPP run attaching to a physical NIC has happened. The only thing that's different, and you might find it instructive to read through the comments on the issue, because there was a little bit of niggling around for this. The only thing I think that would be different in your case would be, for the Calico VPP case, the tunnel IP that's being provided in the NSM tunnel IP environment variable is still the pod IP, because we're running in host networking. In your case, you may have a different tunnel IP that you would provide in that environment variable.
Yep.
But otherwise, you would have the same outcome. Does that make sense?
Yep, absolutely. And I just want to point out that basically we're doing the same thing with the OVS forwarder. As I pointed out last week, this will be shared between NSM OVS forwarder, and the OVS instance will be shared between that OVS forwarder and an OVS CNI.
And this is fantastic, right? That's actually goodness, and it's an ongoing proof point of the wisdom of keeping NSM relatively orthogonal to the things that CNIs are doing, so that we're unlikely to stomp each other. Because as I'm sure you know, because you've been around in networking for a long time, if you talk to any old networking, any networking person about what they call split brain, having a single data plane with two things trying to tell it what to do, most old hands will freak out, because the probability for that going badly is really high usually. But because what network service mesh does is, generally speaking, almost entirely orthogonal to what's being done by anything else that would be using that data plane, it ends up being quite doable. So, but thank you for reminding me. I completely forgotten that discussion. Although I think part of the reason why this ended up being so easy is because when they asked, it turned out that 99% of everything that needed to happen to make this possible had already been done in the the existing VPP forwarder. Precisely because you had asked previously about being able to do that. Cool. Anything else? All right. So in that case, I'm inclined to yield back the remaining 5 minutes of the time and see everyone here next week.
Thank you.
All right.
Thank you. Bye.
See you later.
Bye.